Hi guys, Mr. Lee's here doing the higher paper from 2021, paper 2, and we're on question 9, where you have a cylindrical tin of baked beans which has a volume of 450. We'll need that later on. The radius of the tin is R and the height is H. So there's R and H there, and I just put that over there into this diagram here. Show that the surface area of the tin is given by that formula there, and determine the radius that will minimise the area. So the first thing you do is you realise that that formula there has nothing to do with H, so we need to get rid of it. Anyway, here we go. So the volume of a cylinder, now you have to remember this from Nat 5, is pi r squared H. So because the volume is 450, so pi r squared H is 450, so H is 450 over pi r squared. So that is a nice substitution for H that we'll need later on. So the surface area of the tin, well, what do we have? We have two circles and a rectangle. So we have pi r squared for that one, pi r squared for this one, and this one here, the area of a rectangle, length times breadth, and this here is the circumference of a circle, the circumference of that there, which is 2 pi r. Again, you have to remember that from Nat 5. So the area of this bit here is 2 pi r times h. So we have a formula that has 2 times pi r squared plus 2 pi r times h. Now remember, the final formula doesn't have h, so we're going to replace h with what we got just up there. And tidy it up, 2 pi r squared plus 2 times 450, 900, pi's cancel over r, and you just check that that's exactly what you want. There it is there, that's us done fine. So let's get on with determine the radius that will minimise the surface area. So hopefully you realise this is all about differentiating. And here we go here. So the area in terms of r is 2 pi r squared plus 900 over r. Let's move that upstairs. So we have the area in terms of r is 2 pi r squared plus 900, and that r becomes r to the power of minus 1. The minimum area occurs when E dash r is equal to 0. So let's just differentiate this now. So 2 times 2 pi is 4 pi, r to the power of 1, plus 900 times minus 1 is minus 900, r to the minus 2. And we have to set this equal to 0 here. So let's set that equal to 0. And the first thing we have to do, and you'll notice I've just moved that downstairs because it looks a little bit easier there. Move that over there, change the sign. And then we're just going to solve this. So you've probably been shown how to do this. The r squared goes up there to become r cubed, and the 4 pi comes down here. So if r cubed is 900 over 4 pi, so r is the cube root of 900 over 4 pi, which is a cube root of 225 over pi. Again, we use our calculator and we get 4.15 to 2 decimal places. Now we have to be careful. Does that actually correspond to a minimum? So what we do is here we test the gradient either side of our solution there of 4.15. So we pick a number slightly less than 4.15 and we find that we get a negative gradient. 4.15 of course gives you 0. Number slightly bigger than 4.15 gives a positive gradient. So we have negative, 0, positive. This corresponds to a minimum. So r equals 4.15 does indeed correspond to a minimum area.